Learn Physics at Home, Episode 1.1, Scalars and Vectors. If you enjoy these videos, give us a like and subscribe. This video is not going to do resolving of vectors. Resolving of vectors involves taking components, such as the horizontal and vertical component, and finding the resultant, or taking the resultant and an angle and finding the components. That's going to be covered in episode 1.2. So in this video, we're going to look at all of the different quantities in physics that are scalars and those that are in vectors. If you haven't done any physics further than this, this is going to involve a bunch of memorization. If not, this is going to be some really good review and go over not just the quantities, but also their units. Now, as a definition, a scalar is something that has magnitude only. Now, what does that word magnitude mean? All it means is how much or how many. So, for example, if I say I have 6 apples, I have told you an amount. I have told you the magnitude 6 of apples that I have. And that's it. That's all a scalar is. But a vector has magnitude, which means that it tells you how much or how many, but it also tells you direction. A good example of this would be velocity. Velocity is not just how fast you're going, but how fast you're going and which way. How fast you're going is called speed, and that's a scalar. So for example, if you're driving down the road at 10 meters per second, you've described your speed of how much or how many value that you have. Velocity, you might say I'm going 10 meters per second east, or 10 meters per second to the right. That's going to be a vector quantity because we included direction. So let's go ahead and look at all of the different relevant quantities that we need to know the difference between scalars and vectors in physics. So the first one is time. And although you can travel forward and backward in time, time doesn't have a direction like east or west or to the right or to the left. So time is a scalar. Distance and displacement. These are similar but not quite the same. Distance is the total path traveled. Displacement is how far you've gone from start to finish with direction. So distance is just how far you went. You went for a hike and you went 3.2 kilometers. That would be a scalar. Whereas displacement would be how far away from the start that you ended up, perhaps 2 kilometers, and northeast or to the right. So that's a vector quantity. We talked about speed before. Speed is how fast you're going only. So a speedometer in your car tells you your speed, but it doesn't tell you your direction, so it's not giving you that vector piece. So speed is a scalar, whereas velocity is telling you not just how fast you're going, but what direction. So that's a vector. Acceleration. I wrote all here because every type of acceleration has a direction. That includes centripetal acceleration, linear acceleration, tangential acceleration, all types. The unit is the meter per second squared. And that will come up again in a later video as to where and what that squared part means. Accelerations are caused by a net force. Forces are pushes and pulls. So if I push something to the right, it accelerates to the right. Therefore, it has a direction and it's a vector. Mass, on the other hand, is a scalar. Mass doesn't have any direction to it. Mass is the resistance to acceleration. So if I have 4 kilograms of mass, I could take that 4 kilograms and put it anywhere in the universe, on the moon, on Jupiter, on Earth, out in space. It's going to be 4 kilograms regardless, and it's not going to have a direction associated with it, so it's a scalar. Weight seems like it might be a scalar because you say, oh, I jump on a scale and I'm 160 pounds. But you actually have a direction, and that direction is down. The acceleration due to gravity has a downward component, so your weight has a downward component. So therefore, weight, which is measured in newtons, is a vector. So we really wouldn't say 160 pounds, we might say 820 newtons. All types of forces. Forces are pushes or pulls. So you push things and you pull things in directions. So every type of force, force of tension, force of friction, a net force, force of gravity, like weight, every single type of force is measured in newtons and has a direction. So it's a vector. Momentum. Momentum's kind of strange. It has a lowercase p as the symbol, and that's in kilogram meters per second. And if you think about, let's say, a football player running towards you or away from you, they have momentum. They have mass and they have velocity. But the way that they hit you is going to change. If you have a head-on collision with a football player, that's very different than getting hit from behind. So those two differences in direction make a difference. So momentum is a vector. Impulse also has a strange symbol. It's the uppercase J. And impulse is how much force is exerted through a time. And that ends up having a direction because you're pushing on something in a direction for a certain amount of time to gain a new change in momentum. And that is a vector quantity. Work is force times displacement, but it's called a dot product where we say force dot displacement. And that means that the energy that's gained actually doesn't have a direction. It's measured in joules, so it's a scalar because it doesn't have direction. So an example would be we do work on an object and it gains gravitational potential energy, or it gains spring potential energy, or it gains kinetic energy, or work is done to overcome friction and it produces heat. All of those types of energy don't have a direction associated with them, so they're all scalars. Power is the rate at which work is done. It's how quickly we do work. It's measured in watts, and because energy is a scalar, power is also a scalar. All types of fields have direction to them. Electric fields, magnetic fields. An electric field is defined as the direction of the force on a small positive test charge. So if you place a small positive charge in an electric field, it's going to feel a force, and the direction of that force is the direction of the electric field. Magnetic fields aren't covered in Regents physics other than the shape of the field, so I don't have the symbol, but the symbol is actually an uppercase B. In electricity, everything else is a scalar. So we have charge Q, that would be the charge on an electron or a proton, and current, the rate at which electrons flow through a wire, V, voltage, that would be potential difference or potential drop, resistance, how much a wire or an element in a circuit slows down electron flow, that would be also a scalar measured in ohms, and frequency comes up in the waves unit, and this is how many cycles per second are completed. So this does not have a direction associated with it, so it's a scalar. And finally, all constants, so the universal gravitational constant, the electrostatic constant, these have no direction associated with them, so they're all scalars. At this point, download the questions from inside the description and do your best to complete them and check your answers on your own. If you get stuck, I'm going to go over all of the solutions right now. So, like I said at the beginning, unfortunately this does involve quite a bit of memorization. So scalar is to vector as. So let's look at these. Speed we know is a scalar. Velocity is a vector. So scalar is to vector as a scalar quantity is to a vector quantity. So the answer is 1. Number 2, which quantity has both magnitude and direction? We remember magnitude is how much and direction is which way. So they're looking for something that is a vector. And of these 4, energy, power, and work, those are all scalars. So impulse is a vector. Which term identifies a scalar quantity? So we know displacement is a vector, momentum is a vector, velocity is a vector, but time has no direction associated with it. Time is a scalar, so that's our answer. Which quantity is a scalar? Comes back to a memorization. Mass is a scalar. You push in a direction. Things that travel with a mass and a velocity have a direction, acceleration have a direction. So mass is the only one that's a scalar. Which quantities are scalars? We have speed and work. Speed is a scalar, work is a scalar, so the answer is 1. Vector, vector, scalar, vector, vector, scalar. So the only ones in which both are scalars is choice 1. Which quantity is a vector? Remember that you weigh in a direction. So you have weight down, so weight is a vector. A unit used for a vector quantity. So this adds a little bit of a trick. Watts go with power, and power is a scalar. Newtons go with force, and forces are pushes or pulls in a direction. So that's our answer, number 2. Kilograms goes with mass, mass is a scalar. Seconds go with time, time is a scalar. So it's not neither of those. Which combination correctly pairs a vector quantity with its corresponding unit? Weight is a vector, but the unit is the newton, so this isn't right. Velocity is a vector, and its unit is the meter per second, so this is correct. Speed is measured in meters per second, but speed is a scalar. Acceleration is a vector, but the unit is meters per second squared, not meters squared per second. Number 9. Which pair of quantities represent scalar quantities? Displacement and velocity are both vectors, so that's not right. Displacement is a vector, time is a scalar, so that's incorrect. Energy is a scalar, velocity is a vector, but both energy and time are scalars, so this is our right choice. And finally, number 10, which is not a vector quantity? So we're looking for a scalar, and electric charge is a scalar. Fields are vectors, velocity is a vector, and displacement is a vector. If you enjoy this content, give us a like.